So we've backed away a little bit on our drawing to show all of the different features of the drawing that we're talking about. On this side of the drawing is all the treatments that we did to the lens to bring it up into a configuration where it's easy to visualize. This is where we've described the boron nitride structure. It's basically a die. It's like a type of printing or stamping printing where this boron nitride die will be pushed into the back of this sapphire lens or sapphire cover. And we're showing the boron nitride die coming closer and closer to the sapphire, and at this point the boron nitride die has been pushed into the back of the sapphire cover. This process that we're describing takes advantage of a feature of many materials, most ceramics, most glasses, most metals actually. It involves what is called the brittle ductile curve. It is a curve of the amount of brittleness, which is the rigidity and stiffness of a material compared to its ductility, which is its ability to be pushed and formed and stretched. For most materials, there is a temperature where they change from being a brittle material into a ductile material. So that if we took a metal object like this boron nitride metal die and pushed it into sapphire, which is a type of ceramic, if we pushed this into that, the sapphire would shatter or crack or break apart. Because the sapphire is brittle, it's a ceramic glass. However, as we heat the sapphire up, it becomes softer and softer. The temperature transition for sapphire, where it changes from being brittle to being ductile, is 1500 degrees centigrade. So if we held this sapphire lens at 1500 degrees centigrade and had this boron nitride die at a temperature near that, then when we push the boron nitride die against the planar flat back surface of this sapphire cover, what would happen is you would stamp into the sapphire the size and shape configurations that have been put into this boron nitride die face. I should mention that originally the thought was that this boron nitride structure would actually be a boron nitride printing of the letters and the cross and the shaped structures that hold the gemstones. But as I more carefully investigate 3D printing with boron nitride, it's not so clear that that can be done. However, this is a printing that's easily done with titanium, and you can then take a plasma jet and just plasma deposit boron nitride onto the titanium metal structure. The important purpose of boron nitride in this situation is that the boron nitride is used as a mold agent or a release agent, because the boron nitride surfaces, boron nitride coated surfaces, they don't need to be solid boron nitride. It would work just as well if this was a solid surface that was coated with boron nitride. When you take boron nitride and press it into the back of a ceramic material and then pull the boron nitride back, it doesn't stick to the ceramic material. We can now show that we have taken this boron nitride die face or boron nitride coated die face and we've pushed it into the sapphire cover lens. My thought would be that this sapphire would be at 1500 degrees C and this boron nitride die face would be at 1300 degrees C. That actually this boron die printing activity would occur in an oven at 1300 degrees C.